Is your packet the right packet or you have the weird packet? Can everyone tell me what their note packet looks like? What's their next page? Yeah, they're all wrong. I'm glad that I have these. That's fine. Everyone has a pink warm-up sheet, correct? Yes? Okay, throw those green packets away. They're all wrong. If you give them their notes, I'll give them their homework. They got to turn 25. Throw your green packets away. They're not right. You got to turn that away. Throw it away. Throw the whole thing away. Your homework should be in your pink sheet anyway. Oh, okay. Yeah, it's the. Oh. You have two of them. Yeah, you have a 6.4 homework and you should have a 6.4 notes. Okay. I gave him the homework. I know, 2 homework. Oh, that's gotcha. This is notes. This is her homework. Okay. That is really difficult. So one of you gets the homework. Yeah. So this is homework. And we'll come around. I'll pass out some staplers. You only have notes? Yeah, I have notes. I'll take one of them. Okay, do you have everything? So put your multiply polynomials 6.4 notes on the top. It looks like this. It's got a big old square on the top. But this I want on the top. And then the worksheet, like the homework, is going to go on the bottom. Yeah, this is the front. Okay. Will you staple the rest of those, Carly? All the copies for there. No. We just staple and pass it all the way back. Staple and pass it around. Staple and pass it around. Big one is going to go into your back, like into your binder or whatever, because I'm going to collect this on Friday. Remember how I used to collect warm-ups? Some kids are not doing their warm-ups at all. So I'm going to start collecting them again. It's just easy points. Huh? Does it say no? Yes. Do you have the homework sheet? What? Sorry about that, ladies and gentlemen. Fun Mondays. Okay, here we go. So today we're multiplying a polynomial by a binomial. So up to this point, we've taken a polynomial and multiplied it by a monomial, meaning one term on the outside. We've taken a polynomial and multiplied it by a monomial, one term on the outside. One term on the outside. Well, now we're going to take a polynomial and multiply it by a binomial. Two terms on the outside. Two terms on the outside. Okay? So there are 3 different methods that I'm going to teach you to do this. These are your notes and homework for today. This is your warm-up. I'll put it back up on the board when we're done. So 3 different methods. The first method is distributing. Actually 4. So the first method is distributing. You guys have been distributing since at least 6th grade, taking a number outside of the parenthesis and multiplying it by the inside. The second method that we're going to use is the box method, which seems to be like one of the most popular. It's like an area model. I don't really care for it, but you guys seem to like it really well. The next method is called FOIL, which is exactly the same thing as distributing. And then the last one is the vertical method. So I'm just going to start by going through each method. So the first method, the distributive property, you divide the first polynomial into independent terms, and then you multiply the second polynomial by each term, meaning you're going to take the first grouping. So if I look at that first example, the 2x minus 4, I'm going to pull that 2x out and multiply the second parenthesis by 2x, 2x, and then I'm going to take the negative 4 and multiply the second parenthesis by negative 4. So here's what it looks like. I'm going to take this 2x out, and I'm multiplying both things. So I'm taking 3x, I see it, 3x minus 6. Taking 3x minus 6 and putting it in there. So 2x times 3x minus 6. And then I'm taking the negative 4, and I have to multiply it by the second parenthesis. So negative 4 parenthesis 3x minus 6. And then I just actually do the multiplication. So let's see. 2x times 3x is, yes, ma'am, 6x squared. 2x times negative 6 is negative 12x. Negative 4, right, because this is a negative. So negative 4 times 3x is negative 12x. And negative 4 times negative 6, a negative times a negative is a positive 24. So it says, don't forget to combine like terms and put the simplified polynomial in standard form. Do you see any like terms that we can combine? Negative 12x and negative 12x. So this ends up being 6x squared minus 24x plus 24. And this is in standard form. This is actually in standard form. Okay. Let's do the next one. So notice that I have a binomial, but this is getting multiplied. This binomial is going to get multiplied to this whole polynomial. So the 4x is going to be multiplied into that whole second polynomial, 5x squared minus 4x minus 2. And then the second term of the first binomial is going to get multiplied into the second parenthesis, 3 times 5x squared minus 4x minus 2. And then we have to actually distribute, okay? So what is 4x times 5x squared? 20x cubed. What is 4x times a negative 4x? Negative 16x squared. What is 4x times negative 2? Negative 8x. Positive 3 times 5x is 15x squared. Positive 3 times negative 4, negative 12x. And positive 3 times negative 2 is negative 6. So remember what I underlined up there. Make sure that you do what? Make sure that you do what? Combine like terms. Yeah, we have to combine like terms and put it in standard form. Just at this, will you make her, I think needs 35. And she's going to need that walnut copy too. Sorry. Okay, so combining like terms. This 20x cubed has no matches. 20x cubed all by itself. What's going to come next? Yeah, this should be squared. What's going to come next? When I combine these, I have a negative 16x squared and a positive 15, which equals, yeah, negative x squared. Good job. Okay, then what can I combine? Negative 8 and negative 12 give me same signs, add and keep, negative 20x. And my last term, negative 6. Okay. So this is using the distributive property. This is what that looks like. Okay. The next example that we're going to do is with the box method. So the box method allows you to find the product of the polynomials by breaking the terms of the polynomials into boxes that form a rectangle. If you have a binomial times a binomial, your rectangle is going to be a 2 by 2. If you have a binomial times a trinomial, 2 by 3, and so on, okay? Still the same idea. You have to remember to combine like terms and put your polynomial in standard form. So when we use the box method, we take each polynomial. So for this instance, I have a binomial. So I have 3x and -5. And then my second binomial is a positive 5x and a positive 2. Positive 5x and positive 2. So we're going to use the area. This is called the area model because remember with area, you take the length times the width. So for this box right here, we're going to take 5x times 3x. Well, 5x times 3x is 15x squared. Okay. For the next box, well, this side is still the 5x, and this is -5. So what's 5x times -5? -25x. Alrighty. And then for the next box, I have 2 times 3x. Well, 2 times 3 is 6. Bring down your x. And then for the last one, 2 times -5 is -10. So almost always, not always, but most of the time, the diagonals are like terms, and you can combine them. Most of the time, the diagonals form like terms. So when I think about this, there is no other x squared, so this is just 15x squared. But I can combine my terms on my diagonal. I have a positive 6x and a negative 25x. A positive 6x and a negative 25x. What does that give me? Negative 19x. It's not squared. We just kind of go along with it. Negative 19x. And then my last term all by itself is -10. So this is my simplified polynomial in standard form using the box method. That's a binomial times a binomial. Okay. Example number 2 is a binomial times a trinomial. So this 2 terms, the binomial, this has to go on the side that has the 2 boxes, 2x and -3. And then the 3 terms are going to go across the top, x squared, -4x, and -5. Still going to multiply. So let's see, 2x times x squared is 2x cubed. 2x times -4 is -8x squared. 2x times -5 is -10x. -3x times x squared is -3x squared. -3 times a -4 is a positive 12x. And -3 times -5 is a positive 15. So notice that this diagonal right here contains 2x squared terms, and this diagonal right here contains 2x terms. So when I combine my like terms, let's see, my first term is going to be 2x cubed. My second term, I have a -8x squared and a -3x squared, which gives me a -11x squared. I have a positive 12x and a -10, which gives me a positive 2x. And the last one, plus 15. What do we think? Easy? Okay, so of the 2 methods that we've learned so far, do you like the box or the distribute better? The box, okay. So we're going to do a sample problem of area. which is kind of like the box method, right? It says find the area of the shaded region. So what's happening in this example? What's really going on? Yeah, but what's happening? Like what do I have taking place? I have a large rectangle and what's being taken from it? Yeah. So we have to find the area of the large rectangle. And from it, we have to subtract the area of the small rectangle. That's really what's happening here. So let's see the area of the large rectangle. Well, that has a measure of 3x plus 2 times x plus 15. So I'm going to use the FOIL method, or I'm just going to distribute. What is 3x times x? What is 3x times x? 3x squared. And then I have 3x times 15. 3x times 15 is positive 45x. 2 times x is positive 2x. And 2 times 15 is positive 30. Can I combine some like terms in there? Yeah, what can I group together? What is 45x and the 2x? Yeah, 47x. So I have 3x squared plus 47x plus 30. That is the area of the large rectangle. Now we have to find the area of the small rectangle. Well, the small rectangle has a side measure of 2x and a side measure of x plus 1. So when I distribute this through, what is 2x times x? Jaden is not the only one in the room. 2x times x? Thank you, 2x squared. And 2x times 1 is a positive 2x. What are we doing with this area? We have to do what with the area of the small triangle or small rectangle? Yeah, we have to subtract it from this, okay? So I'm going to distribute this negative. So that gives me a negative 2x squared and a negative 2x because we're subtracting it. So let's see. I have 3x squared minus 2x squared. Seamus, what is 3x squared minus 2x squared? 3 minus 2 is 1x squared. What is a positive 47x minus 2x? Gianna, positive 47 minus 2. 45x. My last term, this positive 30 doesn't have anything to get matched with, just gets put back in the polynomial. So the area of the shaded region is 1x squared plus 45x plus 30. Remember we put it in a parenthesis, units squared, because this is area. Area of the shaded region. So we had to figure out the area of the large minus the area of the small. Area of the large minus the area of the small. Okay, we have two more methods. So we've talked about using the distributive property and the box method. Flip it over. We're going to talk about foiling and the vertical method. We're going to talk about using FOIL and using the vertical method. Okay. All right. So FOIL, this method only works. This method only works when you have a binomial multiplied by a binomial. Okay. It's an acronym and it tells you which term to multiply. Don't forget to combine like terms and put the simplified polynomial in standard form. So I told you when we were talking about these that FOIL is the same thing as distributing. It's the same thing as distributing. It's just an acronym. It's just an acronym that helps you remember, I guess, the order that you need to distribute. So the FOIL acronym comes from first. We're going to take the first term of the first parenthesis times the first term of the second parenthesis. Outside, we're going to take the outside term of the first parenthesis and multiply it by the outside term of the second parenthesis. Inside, we're going to take the inside term of the first parenthesis times the inside term of the second parenthesis. And last, we're going to take the last term of the first parenthesis times the last term of the second parenthesis. But again, this is the same thing as distribute. That's all it means is distribute. Okay. So I don't know why, but whenever we teach the FOIL method for Math 1, kids just get so distraught by it. It's not disturbing at all. Think about what we're going to do. We're going to take 2x and we're going to multiply it by 3x. That's the first term times the first term. What is 2x times 3x? Perfect, 6x squared. All right, the next thing that we're going to do is take 2x times -7. That's the outside of the first parenthesis times the outside of the second parenthesis. What is 2x minus 7? Good job, -14x. Now we're going to take the 5, right? Because we've taken care of the 2, the first term. We're going to take this 5 and multiply it by the 3x. That's the inside. These are the insides. What is positive 5 times 3x? Positive 15x. And then we're going to take this 5, which is the last term of the first parenthesis, times the last term of the second parenthesis. 5 times -7 is -35. All we've done is distribute. We have been drawing arrows to show distribution since I've had you guys in class, right? So let's combine some like terms. What can I group together? What is -14x and 15, Jaden? Good job. Is it -1? +1, right? Okay, so I have 6x squared plus x minus 35. 6x squared plus x minus 35. So we're going to use the FOIL method 2 times. We're going to use the FOIL method 2 times. Notice that we have 2 binomials. We have 2 terms and 2 terms. So let's see. The first times the first. 4c times 2c is 8c squared. Good job. Outside times the outside. 4c times -3 is, good job. Inside times the inside. -9 times 2c is, good job. And last times the last. -9 times -3, positive 27. So when I combine these, what do I get? What happens when I group these together? Yeah. So I have 8c squared minus 30c plus 27. All right, so on this next one, I'm going to call people out. All right. So FOIL, first times first. Caden, what is 3x squared? Sorry, 3y squared times 2y. Remember the rule, multiply your coefficients first. 6, and then y squared times y is y to the, there's a 1 here. Good job. Outside, I'm going to take the 3y squared times 1. Kimber, what is 3y squared times a positive 1? Yeah, plus 3y squared. Uriah, inside, -2 times 2y. Inside, -2 times 2y. Awesome. That's all right. So last is yes. -2 times 1 is -2. Good job, Uriah. All right. Can we combine any like terms? No, we cannot. This is just what it is, right? There are no terms to combine. So 6y cubed plus 3y squared minus 4y minus 2. Okay. The vertical method works for some kids, and some kids it just does not work with them. But it's how you learned how to multiply, right? It's the same way that you learned how to multiply like a 2-digit times a 2-digit number or a 2-digit times a 3-digit. You use that same method. So you're going to stack them up. So I have 4x plus 3 multiplied by 5x minus 6. The key here is just to make sure that you're combining like terms. Okay, so I'm going to take this -6 in the bottom and I'm going to multiply it by both terms. So what is -6 times +3? -6 times +3 is -18. -6 times a positive 20 or positive 4x is -24x. Okay. Much like when you multiply a 2-digit by a 2-digit, remember that when you go to the second digit, the tens place, you have to drop down, right? Do you remember that? You drop down. So now we're going to take this 5x and we're going to multiply it by the 3 and the 4x. What is 5x times 3? It's 15x, and I need to put it right below the other x term. I'm going to put it right below the other x term. When we did multiplying 2-digit by 2-digit numbers, you would actually put a 0 here as a spacer, right? What is 5x times 4x? Positive 20x squared. Okay. So just like when you learned how to multiply vertically, 2-digit by a 2-digit, once you're all done with your products, you just sum those together, right? You add them up. Well, -18 plus 0 is just -18. -24x plus 15x is -9x. And this positive 20x squared doesn't have anything to be added to. What are your thoughts on that? Jansen's like, who said they like it? Or did someone say they don't like it? Don't like it? Don't like it? You like it, Braden, or no? Don't like it? Okay. Can we do one more this way just so everyone gets a chance to? Okay. So think about this as a 2-digit number times a 3-digit number. Which one do you put on the top if you're stacking them up? You always put the what number on the top? Yeah, the bigger one, the one with more digits, right? So we're going to start with 4p squared minus 3p plus 6. Why am I able to change the order of this? Why can I change the order of this? Changing the order of the multiplication. Why is that allowed? Yeah, 2 times 3 is the same thing as 3 times 2. It's commutative, right? Multiplication is commutative. So below that, I'm going to stack this positive 3p minus 7. So I'm going to take the -7 and I have to multiply it to every term in the top. So let's see, -7 times 6 is -42. -7 times -3 is a positive, -3p is a positive what? 21p. -7 times 4p squared is, good job, -28p squared. Awesome, Cameron. Okay. So just like when you would multiply numbers, not polynomials, we're going to jump to this second grouping, right? So we're going to have to go down a level, and I'm going to put a 0 here as a spacer. I'm going to multiply each one of these. So 3p times a positive 6 is a positive 18p. Positive 3p times negative 3p is, good job, -9p squared. And positive 3p times 4p squared is, good job. And now we just add, right? We're just going to add these terms together. Negative 42 plus 0 is negative 42. 21p plus 18p is positive 39p, right? Positive 39p. Negative 28p and negative 9p. Give me a negative, and those are p squared, sorry. Negative 37p squared. And my last term, 12p cubed, doesn't have anything to add to it. Just bring it down, 12p cubed. So we've combined all of our like terms. We've got it in standard form. I like that method just because that's how I was taught. You know, that or distributing, right? It just makes sense to my brain because that's how we learned how to multiply multi-digit numbers. So what method do you guys like the best? Box? Everybody likes the box method the best? Okay, that's good. That's good. Whatever method is going to work for you, right? That's what we want. We have another area. Find the area of the shaded region. I'm not going to do this one for you. You guys are going to walk me through it. What do I need to do first? It's just like the one we did on the front. What do I need to do first? Yes, you may. What do I need to do first? Flip over. What did we do on the last example on the front page? We subtracted the little box at the very end. What do I have to find first? Say again, Jaden. Nope, we're not finding the perimeter. Area of the large box. Area of the large. So I'm going to do this like a box since you guys like this, okay? So I have a 3x plus 2 and a 2x minus 1. So they're both binomials, so I need a 2 by 2 box. 3x plus 2, 2x minus 1. Does it matter which one I put on the top and which one I put on the left? No, because remember, area is commutative. It doesn't matter the order, okay? So get your little box drawn. Someone tell me what 3x times 2x is, Bailey. 3x times 2x is 6x. Good job. Noah, 2x times 2. 2x times 2 is 4x. Good job. Matthew, 3x times negative 1 is 3x times negative 1. Lorenzo, negative 1 times 2. Negative 1 times 2. Say again. Negative 1 times 2. Negative 2. Remember that typically, not always, but typically you can combine the terms in the diagonals, right? So what do I have left? Well, I have 6x squared plus x minus 2. So this represents the area of the large. This represents the area of the large. Let's talk about the area of the small. Gianna said we're going to have to subtract them. Can I use the box method for this? I can. I can write a box with this. I have x on the outside, and then on the top, x and a positive 3. You can sure draw a box for that, right? So 1 by 2. So x times x is x squared. X times 3 is a positive 3x. So this gives me x squared plus 3x. Gianna, what did you say that we were doing with the area of the small? We were going to do what with it? We're going to subtract it from the large. So I have to make sure that I distribute my negative. It gives me negative x squared minus 3x. Negative x squared minus 3x. So let's see. A positive 6x squared and a negative 1x squared gives me 5x squared. A positive x and a negative 3x give me a negative 2x. What do I have left? Negative 2, nothing to combine it with. So my area, my total area of the shaded region is parenthesis 5x squared minus 2x minus 2 units squared. Units squared.